Differential flatness is a strong property which has been exploited in the planning and control of highly dynamic maneuvers for underactuated robots. Such approaches are particularly suited to platforms with size, weight, and power constraints, since their performance can approach that of nonlinear model predictive controllers despite requiring orders of magnitude less computational power. The problem is, finding a flat output for an arbitrary system, or even determining whether one exists, is a challenging task usually achieved by trial and error. In this work, we explore how the natural symmetries of mechanical systems can aid in the construction of flat outputs, simplifying the problem and presenting it in geometric terms. Free-flying robotic systems naturally exhibit SE3 symmetry. Roughly speaking, this means that moving the global coordinate system has no effect on their dynamics. Any such symmetry induces a principal bundle structure on the configuration manifold, meaning that at least locally, the system's configuration is determined by an element of the symmetry group, SE3, and an element of the shape space, Tn, describing the joint angles. A trivialization of the bundle essentially amounts to a choice of which coordinate frame is considered to describe the system's pose in SE3. For example, a frame rigidly attached to any body in the system is one valid option. Strikingly, we find that the flat outputs of many mechanical systems can be understood as the group variables of a particular trivialization of a principal bundle describing a symmetry of the system. We therefore raise the question, when does a mechanical system with symmetry admit a trivialization of its principal bundle in which the group variables are a flat output of the system? We call these geometric flat outputs, since they are equivariant and typically global or almost global. The main contribution of this work is a practical sufficient condition allowing us to construct geometric flat outputs. We begin by computing a particular distribution delta, capturing the effects of underactuation. Our task is then to find a section of the bundle which is orthogonal to delta. This section induces a principal connection, HQ, and due to the symmetry of the system, HQ can be shown to be orthogonal to delta everywhere. The section also induces a trivialization of the bundle. Using the orthogonality property and a mild regularity assumption, we prove that the group variables of this trivialization are a geometric flat output of the system. To demonstrate the key concepts, we apply the approach to several illustrative examples, systematically deriving their geometric flat outputs. The results offer fundamental insights with practical applications in the control of underactuated robotic systems.